Okay, we're asked to find the area, and they actually give me the figure, and I think there's a mistake in the notation up here. I got to correct this, by the way. You're not going to see this, but I will correct this. Right? It's not figure 16 on page 50. Not sure what happened there, but I'll correct that. But anyway, we do have the graphs over here, the graph of this, and we have the graph of this over here. All right? So what I want to do is look at the picture and realize there's a point of intersection over here. Now, kind of looking at it, you could guess at it. I'm not saying it would be a bad guess to do, but I want to go through, the work for it. And the work would be setting these two equations equal to one another, and that's when x cubed minus 2x squared plus 10 would be equal to 3x squared plus 4x minus 10. Let's go through the work. What do you get there? You get x cubed, let's see, minus 5x squared. I'm just getting things onto one side, by the way. Minus 4x, and then plus 20 equals 0. And I'm going to factor this now. X squared comes out. And what do you get there? Let's see, you would get x minus 5. Over here, I'm going to factor out a minus 4. And you would get x minus 5. Let's keep going. I get x minus 5. X squared minus 4, which is x plus 2, x minus 2. All right. Now, I'm kind of looking at it, and they're just giving me a partial picture of this over here, but I pretty much know the points of intersection now. And one of the points of intersection, when this becomes 0, would be at minus 2. And certainly that indicate by looking at it. All right, this other point of intersection, just looking at it, I'm pretty convinced that that's going to be the number 2. Now, there is another point of intersection that we're not seeing. It's way over here. It's at 5. But they're only looking at this region over here, so that's all we're going to look at. All right? I do want to get the y values. And how do you do that? Just plug it in. Where's the easiest place to plug in? Probably on the quadratic. And what would you get there? Let's write this down. You would get, I'm going to evaluate this in the quadratic. You would get 12 minus 8 minus 10, which is going to be minus 6. Looking at the picture, sure does look reasonable. Let's do this one over here, and it's evaluating 2. And what would you get when you evaluate 2 in the quadratic? You would get, let's see, 12 plus 8 minus 10, which is the number 10. Again, looking at the picture looks quite reasonable. All right, what I'm going to do next is put a representative rectangle down. Looks like this over here. And we're going to discuss adding those things together. And let's write that down. It's an integration problem now. So the integration is going to occur from minus 2 up to 2. The upper curve is the cubic curve. So that's going to be x cubed minus 2x squared plus 10 minus the quadratic curve. That's the lower curve, by the way. Plus 4x minus 10, and the differential again is dx. So this is the first milestone. What you want to do is look at the key now. You're trying to, build a skill set, and the skill set is, did you get the correct integration down? And this is the integration they've written over here. And let's just take a look, make sure I wrote that down. Yep, I wrote it down. The next thing I want to do is I want to do the integration. I want to get to the end of it. So let's write this down. Equals minus 2 to 2, and you would get x cubed. I'm simplifying the integram, by the way. You get minus 5x squared. This is sort of like a deja vu, I guess. And then you get minus 4x. And then you get plus 20. If you're interested, this should also be written in the K, and I'm hoping that's down for you, looking over here. I do see that. And again, it's part of your study skills, is to look at keys and see how you're doing. Let's keep moving forward and do the antiderivative now. So we're going to get x4 over 4. Remember, every step that you take is a step towards getting full credit. Let's see, that would be 4x squared divided by 2, so 2x squared, and then plus 20x. Limits of integration go from minus 2 to 2, and now I have some arithmetic to do. And we're going to do the upper limit first. Not so bad to do. 2 to the 4th power, that's 2 times 2 is 4, 8, 16. 16 divided by 4 is 4. Minus, well, that's going to be 5 times 4, which is 20. You know what? I made a mistake over here. I'm sorry about that. It's a cube. I just noticed it because it should go 4, 3, 2. Sorry about that. 2 cubed is 8. 5 times 8 is 40, so 40 thirds. Minus, let's see, you get 2 times 4, which is 8, plus 40. Let's do the lower limit. Not so bad to do. I'm going to get 4. I'm going to get plus 40 thirds. I'm going to get minus 8, and then minus 40. I got to do the arithmetic. And what do I notice? 4 minus 4 is nothing. Let's see, minus 40 thirds is minus 80 thirds. Minus 8 minus a minus 8 is 0. And then you get 40 minus a minus 40, which is plus 80. I'm going to add those two numbers together. Common number would be 3. And you're going to get, let's see, 160. All right, mistakes happen. And again, I want to encourage you. If you're going to make a mistake, make it towards the end. We got the integration done. We did the antiderivative. The evaluation can be a little bit tricky sometimes, especially with the arithmetic. But let's take a look, see how we did. Were we able to get to the end result? And we were. We got to the 160 over 3. Thank you.